Okay, I'd like to take a moment to welcome everybody. Welcome to San Francisco Java User Group. Welcome to Pivotal. Is this the first time at Pivotal for anybody in the room? Welcome, very glad to have you here. A little bit of housekeeping. Restrooms are directly behind this wall. There's a hallway there. It's probably easier than going through the wall directly. We have some pizza, some drinks over here. Any other questions? I will be in the back all night. Feel free to come by and I'll help you out in any way I can. Without any further ado, I'd like to introduce Mario. He's going to do some talk about reactive testing strategies for Spring. That's right.
We probably have already experienced black holes in our data center over the past 4 or 5 years since the NSA is already listening to everything, but these are your own personal black holes. So let's avoid that and let's try testing software. Now, this is a quote about CDCs. They're very invaluable. Yes, they help you move between teams very fast. This is kind of like a preachy thing right here. I'm just testing this one out because usually people go like, what is he talking about? Why would he say something like that? That's so preachy. They're invaluable for being able to move fast without breaking other services and causing a lot of frustration with other teams. This is true. This rings true for me because I've been in several teams where we had that type of back and forth, where the contract consumer, or actually the service consumer, was driving the actual the service description of the services that the server guys was developing. But whenever we changed something, they didn't know about it and their tests broke. So for instance, their iOS tests would break because a service was not deployed at the version that they needed it. Now with CDCs, we're able to identify exactly which version of that service we're going to be testing, and therefore certify that version of the server for that version, the current working version of the client, right? So if you're using iOS or web client, you want to know which version of this service you're going to be testing against. And CDCs are really good at identifying that above and beyond documentation alone. That helps. Now, any strict regimen of anything would help alleviate that in the first place. But you know how things get in development shops. Like, we're like cats, and typically cats tend to run around in various directions, and you can't really herd them all the time. So, especially the brighter ones, the brighter cats, they want their own thing. They're going to try to sneak in their own little specification. And, the next thing you know, you're dealing with Facebook, and every 4 months, somebody's wondering, why doesn't Facebook work on my application anymore? It's because they changed the spec. Now, they don't do that anymore. I know Facebook's really good at this. But, for a while, for all of us, that was one of those things where the spec would break every few months. We're trying to be a little bit better about that. Now, for TDD, as far as test-driven development goes, there's only 3 laws that I like to talk about. TDD is a very long and in-depth subject, after all. These 3 rules help keep me grounded, at least. And that was, 1 is I'm not allowed to write any more production code unless it's to make a failing unit test pass. And 2 is I'm not allowed to write any more of a unit test that is sufficient to fail. So basically, if anything that compiles, it doesn't compile. If I get a red line, then I have to stop writing my unit test and go to production and write more production code to fix that failing unit test. And then the 3rd one is I'm not allowed to write any more production code, right, than it is to pass that one failing unit test. So as soon as I'm finished writing that little bit of production code, I have to go right back into test and create a new test in order to develop the next part of the production sprint. Now, those are like little micro sprints, right? You're in the test mode of that sprint, and then you go to production and go back and forth. It's a lot of back and forth, like a window, I guess. The next thing is, these are some bullet points. I have a lot of bullet points in this particular slide deck. Now, I tried to get rid of this, and let me talk about this for a second. I wanted to get rid of the slide deck because I felt like there's too many words in here, and I was talking too much rather than actually coding. And I like to show the code more than actually talk about the theory, but this is all theory. And I think it helps drive it home. But, if you learned anything, if it came out of the slides, well, if it didn't come out of the slides and it came out of the code, let me know. Like, what do you think helped more, the code or the slides? There's always an iffy question, like, did the slides actually work? I don't know. Usually it's the guy talking about the slides that you listen to the most rather than the slides. And that's a lot of words. I don't want you guys reading that stuff. I'm not asking you guys to read that at all. Don't read that. Don't even look at that. Look at me. So Spring Cloud Contract Verifier enables consumer-driven contract development of JVM-based applications, right? So what we're talking about is JSON stubs used by WireMock. So essentially, we're not going to do message routes, but it does support message routes for things like Spring Integration, Spring Cloud Stream, AMQP, Camel, and integrations that are custom that require messaging queues on either side. It also supports its own acceptance testing, which means that the contracts that we write will have their own acceptance testing written in JUnit or Spock, and it'll allow us to basically verify that the contract that we wrote is actually going to match the service that we're deploying it with. The next thing is on the client, on the consumer side, we have the Stub Runner. And the Stub Runner is basically the thing that will find our contract. It'll download our contract. It'll execute our contract as its own isolated container. And then it'll say, okay, well, here's a server. And this server represents, any number of web services or JSON or RESTful services, right? Now, these stub jars are managed by your repository, like Maven or your JFrog or whatever have you on your central repository for your local base. The service discovery is stubbable. I don't talk about service discovery because I'm not a huge service discovery person. How many of you go by Zookeeper or Consul or one like etc.? I guess it's etcd. How many of you are like, I'm using service discovery like every day? Are we doing that yet? Is everybody using service discovery every day? Yeah. Okay. Good. You are great. Awesome. Yeah. So service discovery is like really, really. I would say it's an instrumental cloud piece. It's a foundational architecture piece for your cloud. Basically, you have a number of microservices. You want to deploy them. You want to know who's there. Service discovery is your DNS for your microservices, right? So the ability to actually create new DNS names and mark them with the microservice that they represent is something that's important. Now, if you can do this for tests, that's even more stronger because now you can say, hey, this particular DNS entry, can be backed by a test. So I don't have to have an entirely different environment. I can just say, hey, I'm spinning up new domains, and those domains will go to my test environment rather than the actual production environment. We could probably get into that later. You can see me afterwards. But that's not something that I actually cover in this demo because that's really in depth and requires, pieces of architecture for me to spin up. But I thought I'd like to give you guys a little taste of that because the breadth of reach of the CDC testing framework that we have with Contract Verifier is extremely broad and it's extremely customizable. So there's a lot to learn about it, and there's tons of if you know Martin Grasesic, he probably doesn't go to sleep. He is always writing code, and there's always new things to learn about this. Now, let's go on. Let's look at the Spring Cloud contract locator format. This is the thing that we're going to see later on. This allows us to identify within the Maven repository where our contract lives and how to boot it up. So essentially, if you notice, you have a group ID, artifact ID, you have the version that you're going to bring up, and then you have this classifier. Am I dealing with a development or a prod, or am I dealing with some other environment or tertiary environment? Usually you can leave that alone. In this case, I'm not going to have a classifier. It will always be test. But the last one is the port, and that's important because it tells us which port we can expect to test against. And so usually I have my test bound to a single port, and so therefore that particular port that I have my tests bound to have to match this thing here. We'll show you that later on, about 30 minutes, I guess. Now enough about TDD and the CDC. Let's talk about the other thing. What was that? Oh, reactive. Yeah. Okay. So show of hands. Who here has used the Java concurrency or Scala concurrency with futures, promises, or other event-driven architectures where we have, well, not actors, but an event loop? Great. Okay. So this is no different. This is a little bit the same. It's a little kind of like actors. However, we have is the ability to talk about individual units of asynchronous operations that are scheduled, and that scheduling means that we are putting them on within a ring buffer that's basically going to contain the breadth of our tasks. All of our tasks are essentially scheduled, and that schedule allows us to say, hey, I'm going to pick out whichever one of these things is going to be needed first. If you've used, let me give you an example. If you used Node.js, has anybody used Node.js? Okay, so Node.js uses the event loop, libuv, I think, libu or something like that. Yeah, okay, so it uses that to a good end. It's a single thread. It allows us, if you've used promises, what you're doing is that you're pushing units of work onto a scheduler that says, hey, I'm going to execute this thing here, unless it's blocking. Usually, if it's not like a long computational task and it's I/O, you're just going to quickly ask, hey, are you ready for the I/O or not? And then you're going to move to the next task. Now, it'll do this a million times because I/O usually takes forever, and you have thousands of tasks waiting for I/O. Now, some of them are going to be ready, so you'll see those, and then you'll push the event. You'll say, hey, this thing has I/O, and I'm ready to go. I'm ready to go to the next stage in the stream, or in my schedule, in my task. What this means is we can compose more of a functional, more of a functional type of development. So rather than typing things and waiting for them to block and like pushing things on threads manually, what we have is a way to say, here is a discrete chunk of operation that I want, and this thing should be able to execute by itself, and get scheduled by itself. I could select how it's scheduled. I can say, hey, this thing needs to be on a separate thread, or this thing can run on the unit thread scheduler, or this thing needs to be fanned out to multiple threads and consumed as ready as fast as possible. That probably, I can go further into depth with that. So let's talk about that. So what is reactive? It's three things at its foundation. It's its core. It's fully on blocking with event demand management. This is our back pressure. This is the thing that says, hey, I have an event, and this event is going to, well, not an event, I have a stream, and this stream is going to say, hey, I can handle X number of requests per second, or I can handle X number of bytes, and give me those. You basically tell it how much I can handle. That's what the back pressure is about. It directly interacts with the functional API, completable futures, stream and duration. So if you're using completable futures now, you can hoist them into your reactive event loop and basically take advantage of the benefits by turning those into your Flux mono stream types. Or just run your completable futures within that event loop itself, and you don't have to worry about pushing another event loop that does completable futures. In other words, it's flexible. So if it's legacy, if it's already there, then you can start pushing things over to the reactive concurrency model. Types, whatever types. There are two main types, two top-level surface types. They are mono and they are flux. So because reactive streams represent a stream of data, or like a collection of data, a collection of events, what this means is we are able to say, hey, how many things do I have to take out of this stream? And the flux is a thing that we're going to say is an infinite source of information or of events. And then the mono is a very bounded, what do you call it? Non-infinite thing. It basically says I have one exact event or I have no exact events. In either case, you're going to be pulling data from something called the publisher. This is what backs the mono and the flux. Is a interface called the publisher. Biggest difference you won't notice is you'll see it in code. Let's just move on. Communications. I tend to not go into like the nitty gritty. Like if you want to see, we're going to get into code more. These slides just don't do justice. Like I can talk all I want, but like nobody has to understand anything. So I'm gonna skip over. I'm gonna say I'll just say non-blocking IPC. Basically, the Reactive API allows us to encode, decode data. It allows us to get data across transports, whatever transports we create. And by default, the Reactive spec supports TCP, UDP. The implementation supports TCP, UDP, HTTP, and these WebSockets. I'm pretty sure there's more that supported like gRPC and like Kafka type stuff. And then the idea that you have, once you get things in and out of your transport, you have to get them serialized or deserialized, right? So, you have your transport, and then you have your serial deserializer. And your serial deserializer is like JSON or Java byte stream or XML. Okay, so what that all means is, with those two types that I talked about here, types, the flux and mono, they're backed by this, publisher. Now the publisher is our first type, and the publisher allows us to say, hey, I have something that I want to pull. I'm going to be reading data, and I'm going to be subscribed, which is going to be the subscription. The subscription is my way of indicating here's my handle on this particular stream. The subscriber is a thing that says, hey, this is what you're going to be using to pull data out of this producer. That's the subscriber. So a subscriber says, hey, I'm going to be emitting a type of T. And that publisher says, hey, that subscriber is a type of T, so I'm going to give this person that particular type. It supports functions. These two functions are subscribe for the publisher, and for the subscriber, you have unsubscribe. We won't go into that because those are just things that we use under the surface in order to abstract away our stream interface, right, our flux and mono. At the end of the day, you're going to be using publisher. There's a subscription, which is another high-level type. It basically says, hey, I'm going to request data now. And then there is the idea of a processor, which is your in and out. So instead of just a publisher, or instead of just a publisher or a reader, you're going to have both. You're going to have the ability to consume data and push data. This is basically your transformer. So if you're going to be receiving data on one end and emitting it somewhere else, transformers, processors are the way to do it because they allow you to go from type T to type R. Now, that might have been a little God, confusing because what didn't I mention here? The functions. No, you guys don't need to know about the functions or the methods used to do the actual operations. I can probably delete that slide in the future. Let's talk about operators. So if, like I said before, in a functional language, you have the ability to talk across your code or your data as a collection, right? So like Lisp is like Lisp. What does Lisp mean? Lisp operator, some sort of, it means list. It's about lists, okay? Lisp is about lists, and functional tends to be a lot about lists. So if you use Scala, you have like the collection API in Java. If you use JavaScript, Lodash, you have like this great support for collection and collection operators. You have the same thing here. So like in your typical collections, you have, you know, a filter map, flat map, where you take like a collection of collections and you reduce them down to a single collection of all of the items and every collection across both dimensions. And then you have things like reduce, where you're constantly aggregating data. And then you have repeat, where you just take the collection and you repeat it over and over and over again, or n times. No, this isn't about how that stuff works, about how operators work. This is about like just the fundamental pieces of what you would know, what you want to know about in the reactive world, which is it's functional. It acts like Lisp or list-like collection manipulation across events on a scheduler. And a scheduler that can span threads or can just be a single thread, depending on your demand, right? Demand is also something that we have the ability to control in reactive. That's very important. Now, okay, so let me take a break. And I want you guys to look at this marble diagram. So these marble diagrams can be found at that link below. I would advise anybody who's interested in, I don't know, if you want to dive in to reactive, check out the marble diagrams on projectreactor.io. Anyway, this particular marble diagram, this is our mono. This is what our mono looks like in time. So like at time equals 0, you have like nothing at the very left. There's nothing there. Let's say that time increments to the next event, and the event is 1. It's just a number, it's an integer. So what happens is 1 has to pass through this operator, right? So this operator could be one of our map, flat maps, repeat, reduce, things like that, right? However, once it passes through the operator, you still have the problem of shutting down the stream, right? You have to like say, hey, I'm done. How do you do that? How do you trigger the terminus? And that's where this X is. This X can be an error too. It's the terminus basically. It says, hey, shut the stream down. We're done pushing data through it. In this case, we're gonna look at for some reason where the operator failed, like say it threw an exception, right? And it threw an exception, and it threw a signal, and that signal was a error rather than a complete. It didn't say, hey, I'm complete. It says, hey, I'm having an error. It's a terminus event nonetheless. An error is a completion signal as well, right? So in this case, it's an error signal. And because this error signal happens, we can catch that error signal. And that error signal can be transferred to another mono. And that mono can then say, okay, well, I'm taking that error and I'm mapping it to a default number or something like that, right? Okay, so that's a simple, I guess, way of describing the mono. However, then you have the flux. And the flux, of course, goes through time. And it starts at time equals 0, and then t equals 1, 2, 3, 4, 5, and so on forever. But each one of these events here is an integer, 1, 2, 3, 4. It goes to the operator. It's an equality operator, I guess. You just return whatever you found inside of the event. But somewhere at 4, it says, hey, I have a divide overflow or something. And rather than getting the rest, you get an error and shut down the stream. Now, if you're smart, you would say, hey, like I want to retry. I want to do something. I want to I don't want to dump the stream. I just want to say, hey, I want to take the error and I want to turn it into something useful, or I want to retry that. And you can do that. There's strategies that let you say, hey, if it fails this time, here's a retry strategy. This goes along the lines of what you would do with maybe composable futures, where you have, the repeat, retry, what is that operator for composable futures that you use to take an error and turn it rescue. So if you've used rescue, you would have that similar operator here as well. So rescuing errors is important because it allows us to take errors that ordinarily dump us out of our method, and it lets us retry again. It lets us go, hey, let's try that one more time, but here's a different condition. So that's why I like functional programming. That's why I like reactive. That's why I like things like Scala and Kotlin and Java, because, you know, first of all, they're amazing languages. But second of all, they allow me to get things done, and they allow me to think of things in a slightly different way than if I was writing blocking code. But you know, it's even stranger. If you've written C programs, right? You've done like the whole bind, you've done the whole fork thing. Like, that's the strangest thing in the world, isn't it? Like, when you do fork in C, what happens? You're still running the same line of code, but it's just now you have to imagine it's in another thread, and you're just like, oh God. So like, is this thread 1 or 2? You have to ask the program, which thread am I in? And also, you have to do all sorts of stuff in C to get the same effect. It would be a nightmare to have to do that in any other language, really, other than C especially. But you don't have any of those side effects with reactive code because it's taken care of for you. And honestly, in my opinion, let's make the world better and test our reactive code. So I'm going to show you a couple of things. So first of all, this is Emacs. I have a longing for Emacs. I've been staring into a dark mirror for about 4 or 5 hours. When I got there, I saw an Emacs terminal, and it stared back at me and said, install Kotlin mode, install Java mode, install everything. It tried to get me to install Windows. I stopped it after I started writing assembly in hexadecimal. I couldn't do it anymore. I was like, nope, I'm not cutting myself this time, okay? So the whole idea behind Emacs is a single place for everything. Lisp for everything. This isn't about Emacs. This is really about me at this point, because I'm fixed on Emacs and you guys aren't, and I just can't believe that. Like, I love Emacs. Okay, anyway, demo time. So I have a project I want to start. I want to demonstrate CDC on the producer side. So what do? Where do you normally start? Where do you start for your applications? Do you guys have your own like application, bootstrappers? Because a lot of people do. I've seen people with Uman. You ever use Uman? Uman allows you to create your own bootstrappers that support whatever language and say, hey, I have Kotlin and I want to use it with Gradle and I want to start it with Angular 2 and I want to add all these dependencies to it and it'll set up a project for that. This is kind of our Uman. I would say this is start.spring.io. It's a little better because it's on the web and I can drive it from here. So allow me to, let me get out of VI. I'll stop scaring you guys. What happened? Did I break it? Oh, 1900. Okay, sorry guys. Yeah, it's telling me something. It's like you're almost done, Mara. You go home, you know. Oh God, yes. Sweet release, sweet release. Okay, let's release some code first. Yeah. Yeah, I believe there's localizable. You can create your own changed version of it. So I think people do that actually. People actually take it and fork it and then create something else. That's up to you. If you want to do it, do it. But if you're like me, you just use what's on the web. So I tend to use what's on the web. But I hear people do all sorts of cool things with Start.io. Customizations, yeah. Oh yeah, absolutely. That's right, because you might want to run it locally. You might want to run it locally, right? You don't want to run it from here. You want it to come from your own repositories. Yeah. I'll bring that up. Oh, okay, so we're ready to go again. All right, let's continue. So where was I? I was looking at, oh yeah. So let me go to my bin directory and let me go to, let's see. Okay, so we're doing this in Java, right? So if we're going to do this in Java, let's go ahead and say Bootiful testing. And jug, SFO, that's today. I don't need any of that stuff because yep, see you later. Okay, so we're going to use a model of users. We're just going to create a quick user program, a program that bins a user object. But what we're going to do is we're going to use multiple ways of getting to that user. So we might introduce things like Mongo. We might even introduce Redis. But for most of all, we're going to do testing against these users. So let's check it out. Let's go SIO producer sh. Is that right? Yeah. Okay. Okay, so first of all, I was showing you start.spring.io on the web, and let's go through that really quickly. So I'm going to create a Java project in start.spring.io. I'm going to use 2.1.3 for Spring Boot. I'm going to use a group name of com example, an artifact of demo, and then I'm going to look for dependencies. So this is where I find anything that I need as a dependency in my project. In this case, I'm going to use Reactive Web, which is our web flux. So let me get rid of those that I selected already. Let's go here. Let's type web flux, right? I'm going to need Mongo repositories because I'm probably going to end up using Reactive MongoDB because it's easy to test and it's there. It allows us to do tail queries with reactive streams. And this allows us to get like a really fine degree of pulling data out of Mongo. However, I've done that before and it just doesn't feel right. Anywho. Let's see, we have Reactive Web, we have MongoDB, and the next thing we're going to need is a thing called Verifier, Cloud Contract Verifier. And the Cloud Contract Verifier, like I said before, it's the CDC part for a producer. It'll run tests against our contract that we write, and it'll verify that it can be deployed for clients to consume. The next thing I'm going to use is, because I'm using Java, are you guys using Java, and are you using Lombok? Do you agree with Lombok's formula and method? Do you guys like that, like the whole idea? I have another library that introduces more, class scope annotations, compile time annotations, and it recompiles my code to do the thing that I originally wanted to do without me actually having to do it, which is like writing getters and setters. So Lombok's for you. I like Lombok. That gets me closer to the heart of what I need to type, right? So got Reactive Web, I got Mongo. Yeah, I guess Cloud Contract Verifier and Lombok. If I'm missing anything, I'll find out right now. Web flux contract. Nope, that's it. Yeah, so if I hit generate project, a zip file will get dumped out. Now, I'm not going to use that. I'm just going to go ahead, and from now on, I will issue the web interface. Because it's pretty, and I wanted to show it to you guys. It's like they redid it. It looks really nice. It has this really cool Web 2.0 style, dynamic HTML list accordion or list box going on here. But a lot of our checkboxes are gone. I think people want those checkboxes back. Get those checkboxes back, guys. Who does over here at Pivotal? Who's working behind Spring.io? I need those checkboxes, guys. Those checkboxes were important. Okay, so I'm going to use this curl script here. So if you look at my curl script, it's going to do the exact same thing that you saw up there on the web screen. Only I'm going to just show you that you could do this with curl. In fact, if I did curl start.spring.io, I get this nice help menu. It's very helpful. It tells you exactly what options are available so that you can start, writing down the right command with the right arguments that'll get you to the place, to the application that you want to start writing. So if you notice, I did miss something. I did miss flapdoodle Mongo. What is flapdoodle Mongo? Good question. I'll go into that in a bit. But let's first look at this nice help file that start.spring.io emits. And this is HTML. It's emitting ASCII. I mean, I haven't seen that too many times, and I think it's pretty badass, okay? Like, if you want to ask me, this can be an IRC bot or something like that. I would love to see that one day. Or a Slack bot, or you could drive it from anything, really. Anyway. So the command goes, give me starter.zip, which will emit the zip file. Give me an application named demo producer. Give me an artifact for producer. Give me group ID for com example. And here are my dependencies: Lombok, Data, Mongo, Reactive, Webflux, Cloud Contract Verifier. And then here's a base directory. So basically the root of the project will be something called producer. And then it finally, I'm telling curl to output all that stuff into a file called producer.zip. Otherwise, I'll just get my text dump straight into my terminal, and terminals don't like that. So again, what is your favorite way of clearing your terminal? When your terminal is completely messy and you typed it, Command key? Command key, what does that do? Oh. Okay, I was going to say like, I do Control L to clear it and I do STTY sane, because like sometimes your terminals get really out of, like your terminal just thinks it's something else. It thinks it's on the mainframe. It's like, it's trying to print out Hercules graphics. And you're like, no, I didn't want Hercules, you know? But, oh, you, come on. So what was the name of that dependency I had there? I just copied it. Rep flap. Flapdoodle Mongo. There it is. Let me copy that guy again. There we go. Okay, so I want Flapdoodle Mongo in here, because that's gonna get me the ability to test MongoDB. Okay, so let's open that in IntelliJ. I did this jug a few weeks ago in St. Louis, and let me tell you what happened. My laptop wasn't supported by the monitor, but for some reason, I have no idea what happened, you guys. Like magic happened. Magic, like true magic happened. I have a Raspberry Pi with, you know, Rasp Linux in it, Raspbian, and I do a lot of coding on that Raspberry Pi as well. And so luckily, I had everything started. I had an Emacs terminal with the Java interpreter, the auto completion, and wow, it was amazing. I was able to boot up into a Raspberry Pi, attach my keyboard, and I borrowed a mouse, and suddenly I was in VI coding, live coding. That was weird. I mean, not VI, but Emacs. Now, it turned out that, like, you know, as awesome as I try to be, it still takes a while to you know, get the hang of suddenly going from one IDE to the next. But I'll say it's a really nice experience. It was a very nice experience. Okay, so here's our application. This is our basic bootstrapped application. It's a Spring Boot application. It doesn't do much. It will start up. It will probably start up a server even. But we don't need it to, you know, we don't have anything to tell it. So let's start doing stuff. Let's start with tests. I'm going to do it the TDD way. And I'm going to start with some very basic tests, extremely basic tests. Now, let's see. Do we have Jupyter? Yes. Okay, great. So what we'll do is we'll use Jupyter, which is JUnit 5, in order to do our testing work. Great. So I'm getting used to using Jupyter. Is anybody using Jupyter now? How do you like Jupyter? Do you think it's have you found any like tricks to make it like go faster for you, to make it more concise for your tests? How is that? Which one? Assert. Oh yeah. Yeah, the Assert. Yeah, I love the Assert tool, of course. Yeah, all of. That's my favorite one. In fact, that's all I use now. It's like, well, I don't have any need to use Assert J almost. I'm not saying that Assert J. Who likes Assert J? You like Assert J? I like Assert J. Assert J is amazing. Like, I use Assert J all the time. Okay, I'll try to use Assert J too, okay? Jeez. Like, people don't get mad at me if I don't use Assert J. I'll use Hamcrest. Okay, so the first test I'm going to do is, hey, what if I have some data? And what type of data would that look like? So let's say, let's call it test user should hold state, I guess. I don't know. But basically, I'm going to do my getter and setter tests. Remember, don't test your getters and setters. But I want to test state. Kent, let me test the state. User equals new user. We're going to call this user with an ID of 1234 and a name of, no, how about the username? What's a good username? What's our favorite John? Really, John? Okay, we'll use John. Hi, John. Okay, so we got a user named John, and what I need to do is create the user now, because none of this works, and I'll break the law of TDD if I didn't. Hi, just create the actual thing. Oh, okay, whatever. Java class user. Okay, so I have a string, and it's an ID, and I have a string that is a name. So I have a user ID and a username. That's really simple. It's like, you can't get too complicated with that. I'm going to use Lombok to give me a constructor. I want all args and I want no args. Finally, I want data, because this is going to have getters and setters. So I need to be able to say get ID, get name, and then construct the user with and without arguments, right? So we have that there prepared. The next thing I want to do now is say, what if I want to, let's start with Assert J. Oops. Let's see if I even remember how to use assertions anymore. My gosh, it's been a while. Is not null, or let's see, yeah, I can say is not null and has no fields and properties. Okay, so with Assert J, I can do something like that. I can say, hey, tell me, make sure that this thing isn't null and that it has no null fields or properties. But I also want to give it a description. So has full state, no nulls, right? Okay, so there's that. What's the next thing I want to do? I want to test that. Let's see. Let's end that one right there. That's a really simple test. It's going to say, hey, your getters and setters work. Woo! You just broke a rule of TDD though. Why did you do that? I don't know. It was not my fault. The crowd made me do it. Okay, so we'll write the test that does that. I'm changing this up just a little bit because normally I would go into Assert J. I'll test the JUnit stuff, but I'm not doing JUnit 4 anymore. So I'm kind of dropping some of the API that I'll normally test with. I'm going to go straight to Hamcrest, and I'm going to write a matcher. And so in order to do the matching, I'm going to use matcher assert. But let me show you what the Hamcrest supports out of the box for Spring looks like. So I had this idea that I have a matcher and a matcher of the user, and basically it's going to look like there you go, right there. This is a Hamcrest matcher, and I can use my matchers or Hamcrest dot hi. Oh yeah, I'm not using Kotlin. Good Lord. Okay, so simple. This matcher just says, "Hey, is this John? Is this a user? And does this user have a property called name? And does that name match with John? Right? So that's simple for us. But how do we plug it in? Let's go into that in a minute. So this is a Hamcrest matcher. Hamcrest matchers allow you to take that logic and move it around. I really like that ability, and that makes a lot of sense because then you can start composing really discrete matching logic. You can even put this in your code and say, hey, I have really discrete matching logic that'll assert that this state of the object is the shape that I want it to, or else break the whole program. And I like that. We want to fail fast, right? So we want our programs to know, hey, do you have the current known state of this object, or is it, has a hacker gone into it, or has somebody mistyped anything? Test user should. Let's see. So this next thing is going to be a, yes, step verify. Okay. So because this is a reactive demonstration, I'm going to go early. And usually I save this for way later on. And can you guys see this code up here? Is this readable to everybody? Because I can make that bigger. Let me go into preferences, and I'll make that 24. And don't worry, I can read it. It's just I want you guys to be able to read it too, because sometimes it can be a little hard to read even code that a little up on this monitor here. So the first thing I want to do is this. I'm going to create a stream, and that stream is going to contain one user. It's just a simple mono, and it will allow us to test that we can get our user out of the streams, and I can show you what this test component looks like. So let's go here. So I have a mono of type user. So this stream will emit one user or 0 users. And I'm going to create the mono using the .just method. And the just says, hey, take whatever data is in here of that type, which is a user, and create a stream of it. So whenever somebody pulls this stream, they're going to get that one user. Right? So this is our single user mono. Now, because this is contained within a stream and I haven't subscribed to the stream yet, I need a way to subscribe to the stream and assert the contents of the stream. In order to do that, I will introduce a new component, and that component is the step verifier. And the step verifier is our way of testing reactive components of reactive streams. And let me go into the code and read a little bit about Step Verifier for you guys, because for me, this is like cathartic in reading code. You know, every time I look at it, a little bit changes and I get a little bit more knowledge about what it's actually doing. And as you can tell, there's many, many methods in here. So reading this is gonna go a long way. Okay, so a step verifier, it provides a declarative way of creating a verifiable script for an asynchronous sequence by expressing expectations about the event, which will happen upon subscription. This verification must be triggered after the terminal expectation. Completion, error, cancellations are terminal expectations, are terminal events, right? Have been declared. Now, after the terminal expectation has been declared, like, hey, I'm going to expect this thing to end in error, or I'm going to expect it to complete, or I'm going to expect it to cancel the subscription. Either way, I need to know how this thing will end, right? And so what you'll do is you'll call one of these methods called like verify. And I'll show you what that means in a second. So when I call verify error or verify complete, it says, here's the terminal event that I'm going to expect after I've subscribed and received data, right? And let's talk about that in depth. So step verifier, it's creating me a script that allows me to walk a stream. I'm walking the stream, basically. So in order to create an instance, I have to bind the step verifier to a particular stream, a publisher. And this publisher will be of type mono of user. So this is going to be user mono. So I have a step verifier that's now bound to my user mono, and now I can start asking things. Expect first thing that you do is that you're going to expect that the first signal is a subscription. Now remember, subscriptions are signals. So when we pass the subscription, when we say here, subscribe to this producer, to this publisher, that's sending a signal, an actual observable signal saying subscribe, start the stream. And so we can make an expectation about that. The next thing we want to do, we want to say, okay, well, the next thing that's going to happen is I'm going to have some data, and that bit of data is going to look like such. I can say, when this data comes down the pipe, assert next. So assert next allows me to take a consumer and then write some logic, some assertion logic about what's in there. I can throw an exception if it's not the thing that I want, right? So how would I do that is I will say user U, and I can then go match her assert dot assert that user state comma U, the thing that I'm actually matching, and then the matcher, user matcher. Okay, so this assertion basically says here, give this to Hamcrest, and matcher assert is our Hamcrest component that we're going to reuse here. That allows us to compose matching logic. We can compose it this way by using matcher assert. So I'm saying assert that user state U has a user that agrees with this matcher that I defined up above. And then the next thing I want to do is say, oh, am I doing this right? Yeah, I'm doing that right. Then assert next, no, there's only one data object. I can say expect complete. So this means that the completion signal gets sent, and let's make sure that that's the correct expectation here. Expect the completion signal, great, okay. So what we're going to do is we're going to expect three things here. A subscription happens, that's the signal. An assertion, data happens, that's our assert next, which pulls the data out of the stream, and then the completion signal happens. So subscription, data, completion out of the mono. Now, let's see, the final thing we need to do is, so we have an expectation of a complete, and then we want to verify. So this is where things can go a little tricky with verify. So verify the signal received by the subscriber unless a default timeout has been set before construction of the step verifier. This method will block until the stream has been terminated through a incomplete, a throwable, or a cancel. And depending on the declared expectations and actions, notably in case of undersized manual requests, such as a verification, could also block indefinitely. What this means is if I don't drain the entire source, the stream, if I don't drain the stream, my step verifier will block indefinitely. So, or if I have a publisher that publishes really slowly, and I don't expect it to do that, then I'm going to block for a very long time. Step verifier allows you to test those test when you need to have time as a component. I'll show you that later. Now, for a simple thing, we just want to test that the stream works, and this is how I would do it. I think I described kind of, I tried to be as concise as possible with just an hour of sleep, but you know, I can always do better. The code should hopefully read itself. If you've ever done a PR and you haven't seen the API before, what is the first question you normally have? Hi. Correct. Verify does that. Verify triggers a subscription. It actually pulls this button subscription. So that particular script gets executed then when verify is called. Bingo, bango, and it blocks. So it'll block until it's done. And if you have competing schedulers with greedy emitters or greedy subscribers, what you'll end up with is a very, very what do you call it, when your tests run really fast one day and then the next day it runs really slow. Like you can have unpredictable behavior. And so what you want to do is ensure that your step verifier tests have predictable behavior and that your streams conform to the behavior that you want. So you might have to change your code for your Flux stream in order to get the type of profile, performance profile that you're looking for. And those are advanced scenarios where time is really a component. In here, we don't have time as a component. We just have a stream of data. Now, the next thing we want to do is, now that I have a piece of data, I've shown you a component, but what I want to do is also get into the nitty-gritty of this application. And the nitty-gritty of this application is about the user and how do I get it in and out of the database and how do I get it to and from the web so that a user can talk, right? So in that, I will start using the string test slices. In this case, I'm going to create a Mongo. I'm going to introduce the MongoDB test slice. So let's call it demo persistence. I know it's persistence, not like JPA persistence. It's persistence in that it's going to like a permanent store. Okay? I can also call it demo entity test. I don't like the word entity because it reminds me of EJB. Sorry. What's a better name for this test, you guys? So I don't like muddle the water. How about reactive persistence? Okay. Test. Okay. Thank you, you guys. You guys are amazing. Yeah. Did I spell something wrong? Oh, yeah, that's right. I'm not using, guys, great. Yeah, how many times have I done that today? Okay. So you can do that in JavaScript. You don't have to have uppercase in JavaScript. Why do you have to have that in Java, though? I don't get it. Anyway, that's not for me to determine. Let's do our extend with Spring extension class. So we have JUnit here. The next thing we want to do is introduce something called a test slice. My test slices are like this. Are you familiar with Spring test slices? Raise your hands. Test slices, test slices. What do you think a test slice is? It's around that general vicinity, correct? It's the opposite. It's the negative. It's what pieces away parts of our application framework so that we can focus exclusively on one part of the stack, right? So I'm going to focus exclusively on saving, and I'm going to use data Mongo test. So what will this do? This is going to basically, when my class path is scanned, rather than scanning for everything and starting up all of the components like the web and any other resources that I have out there, like say Kafka or something, this is going to exclude those, and it's only going to take in things that are data related to Mongo. So if I have a document, if I have a Mongo repository, it will find those, and I can start testing them exclusively. Yes? They are customizable. They are test slices are indeed customizable. This is one that's out of the box that comes with Spring Boot and allows me to focus exclusively on testing Mongo persistence. Now, testing Mongo persistence means also that I need to have a database. And because I don't have MongoDB loaded on my machine, I need it flapdoodle. So let's go back here to my POM file real quickly and see if I actually got flapdoodle. Yes, I did. So flapdoodle embed, right? So what is this going to do? Right? What this will do is at test time, rather than me talking to a real Mongo server, it's going to, I don't like saying this. Okay, you guys are all computer scientists, right? Okay, we know this is perfectly legal stuff to talk about, right? So what this is going to do is download MongoDB and run it in another thread, open it on a different port than it normally runs on, like say port 50,000, and then it's going to hand that local, it's going to tell Spring, here's your MongoDB, and here's the port that it's on. And then as the test is over, it's just going to dispose of the thread in that Mongo instance, and everything is gone. Now, this is almost like running MongoDB in production, with the exception that your data still might actually be there. Oh, I'm just kidding. No, I like MongoDB. I tried to razz MongoDB really hard, but I've been really bad at that. So that is exactly what I described. It will take MongoDB, download it, run it in another thread, and then I can run my tests against a brand new, fresh database, and it'll tear that down after the test is run. Simple as that. Now, there is a Java-only version. There is a Java-only, but it doesn't support things like aggregate queries and tailable queries as well. So it's a lot harder to get those advanced features out of it if you're trying to test them, which is why I like to use Flapdoodle, because the mind can go anywhere with it. Now, that is not an endorsement. So don't think that I say, hey, Mario from Pivotal said, use Flapdoodle. I didn't say that. You guys can use whatever you want. You can use a Docker image if you want. I don't really care. So in order for this to work, I need a repository, right? So let's do an auto-wired, and let's call it user repository repo, okay? So I don't have a repo yet, and I want to create one. Okay, so I think this will be an interface, right? So this will be an interface that extends reactive Mongo repository, type T and ID. So the type is going to be a user, and the ID will be a string. That's all I need for now. I don't need like any extra repository methods yet. I'm going to do like find all, really. Maybe find all. Don't want to get too complicated. Brain cells need to be split evenly according to like reactive TDD and the actual flesh of this matter. We don't want to get too complicated, right? And also, I'm talking a mile a minute. That can also lead to confusion. When you do PRs, talk as slow as possible. This will catch the PR person off. This will arouse their cop heart, and what they want to do is stop you from talking because they think that they're going to catch you in something. And what you're going to do is you're just going to blow all the way through your code in 5 minutes, and you're not going to stop. So this is how to succeed in PRs. If you guys want to talk about PRs later on without too much heartache, talk to me. I've been kind of like the PR therapist for a while at different places. Okay, so we have an auto-wired dependency. That's our user repository. And then let's see, we could do it before all where we save data into the database, but we don't need to do that. We can save data. We're adults. We can write our tests, and we can save our database data in the unit test itself. So test should persist. Let's call it test should save find. Now, what am I going to do here? I guess I can possibly also even just say, can I do this yet? Is this legal in JUnit 5 now? Is this something that I've been waiting for? Do you know that? Is that like something that I'm gonna go, hey, like, yeah, so it didn't give me an error. All right, so let's see if that works. So what we're going to do is we're going to say, we're going to take a piece of data called user. User equals new user, null, and this will be John again. Hello, John. Let's take our matcher from our existing test, and let's place it in here. I want that matcher. I don't want to write that matcher twice. If this was PR'd, you would definitely say, hey, don't write that matcher again. Put that in a static class somewhere and tuck it away. For now, I'll just copy and paste it. And then I'll say a flux of user, hello, equals user repo dot save user. Yeah, I know. Yeah, Kotlin just did that to me. I'm sorry. User save. Yeah. It's hard to learn. It's hard to unlearn things sometimes. So I'm going to do save, and this is going to be a mono. So this is going to be a publisher. How about we give it a public? Yes. There you go. Come on. There you are. There you go. Okay. So we're going to create a publisher. It's a mono, but it's a publisher nonetheless. They abide by the same, contract. So we're going to save it. We're going to create another publisher of user, call it user find or user query, and we'll just say repo.find all. I mean, that's all. This is going to return a flux of users, really. In the background, you're not going to notice that. So really, that's a flux of user. And then we're going to say publisher, publisher user compose equals flux dot from user save. Okay, and then many user query. Right. Okay. So what did we just do here? I mean, that's a little different from the last time we did anything, right? So well, let me explain this code here in a minute. Let's see. Step verifier dot create compose dot expect subscriptions assert next. I'm going to steal some more code. Who doesn't like stealing code? Well, I'm pretty sure you guys don't like stealing code, so I won't say that again. I'll pretend like I didn't say steal code. You know, expect complete and verify can be done like this. You can say verify complete. So I just wanted to show you that. You can break it up. You can say, hey, expect something else and then verify, or verify with a timeout. But in this case, we don't have that necessity, so we'll just do verify complete. We expect and verify at the same time anyway. It's a little shortcut. All right, so let's explain what just happened here. And actually has no, is not null, matcher has property, ID, matchers that is not null, not null value. All right, so what we're going to do is we added one more thing to our matchers. I know I added a little bit of code here, but it helps, right? Because we know that this is going to a database, and that at first that ID is null, but once it comes out of the database, guess what? You're going to have some data in that ID field, and it shouldn't be null, because if it is, then we have problems. So let's ensure that ID is actually filled in, right? Good. All right, now let's go over this. Let's go over this line by line and look at what's going on. Does this look familiar to you guys? Can you guys grep what's going on? Can I see a show of hands? Is this greppable upon first or second observation? Is this something that you would sit down with a coworker and go, oh, okay, I see what this is doing. Yeah, right? Good question. So good. All right, so let's jump from user save. We get the publisher for the save. We get the publisher for the find, and then we compose it. So what we did was we said, hey, we're going to compose two publishers together. And what I want to do is I want to execute one publisher. I want to execute this first stream. I want to see whatever comes out of it, just complete the stream. Don't worry about what comes out of that stream. So we say from user save, once it's executed, I say, forget about what's in that stream, but execute this next thing, and this is going to become the terminal output of this composed stream. I'm merging streams together, and I'm saying that user query is the ultimate end goal for that merged stream. So let's look at what then mini looks like in terms of Java doc. So what then mini does is it lets this particular flux, the thing that was played right before that line, the save, it lets it complete, and then it plays another publisher, which is the find publisher, right? So in other words, ignore elements from the transition flux and then transform that completion signal into a publisher that will emit elements from the thing that I then mini. So I'm saying complete this source step and then turn that into this guy here. Turn whatever you had from the terminal event of user save, and now turn it into user query. So execute user query, and whatever comes out of user query will be the stream that I end up with. Then I can do then many, and all that does is it goes, from A to B to C to D, E, F, G, and whatever is last is the thing that comes out of that stream. Okay, so, and then step verifier create, give me the composed stream. So whatever comes out of the terminus of this composed stream will be a stream of users, of course. So then I could expect a subscription, and then I can start asserting against it, and then I can verify that it's, I can say here, verify you got a completion signal, and then finally subscribe, execute. Okay, so I'm testing this a little bit. I want to see that injection happen. I want to see that, that auto dependency, that auto wiring happen within my methods. I don't think that worked. Oh, that did not work. Of course it didn't work. So what was it? What didn't it like? Oh, no parameter resolver for parameter producer user repository arg. Oh yeah, reactive Mongo repository is of type T and ID. And yeah, that's right. User, oh, is this the right one? Yeah, that's the right one. T and ID is user, yeah. Reactive Mongo repository is T of user and parameter com producer user repository argz method public void producer demo reactive persistence test find user repository. Perhaps I should move this out. Perhaps it didn't type it correctly in my user repository. This is the same. Yeah, that's my user repository. Okay, fine. It looked okay on first inspection. I was pretty sure. Well, if it didn't null, then nothing could be wrong, right? If it wasn't null, then what's it complaining about? Why is it telling me that the types are not correct? There we are. What's this guy here? Test engine ID JUnit vintage failed to discover test. Oh, I'm using JUnit tests, aren't I? This is an org JUnit. Nope, that isn't. Is there any org JUnit in here? Nope, it's all org JUnit Jupyter. So, oh, did I do extend with? Yes, I did. Gosh. Public class demo reactive, let's execute you. Let's see, what is the test engine with ID JUnit vintage? I haven't gotten that one before. Why did it fail to find it the first time? I don't get it. Ah, gotcha. Of course, okay. Okay, so this time it worked. Okay, I did change that. I changed that method signature, so I had to rerun it. I had to give it a new executor because otherwise I didn't know what to execute. All right, so I did that right. I just forgot how to do the auto injection for parameterized. I guess I have to reparameterize it or something like that. I'll figure that out later. I won't waste your time here. Okay, so this is our test to determine that we can go in and out of MongoDB. All right, so is that succinct, right? You guys can probably PR that and go, okay, well, this is a simple user repository that saves the user and finds all, right? And then I want to go to the next step of the stack, which is the web. So what I'm going to do here is I'm going to segue directly from data Mongo to demo web flux test. So what this will be is a particular test that demonstrates our web serving abilities. We want to just create a REST API, a simple JSON. It's just going to encode JSON and allow us to fetch data from our repository. And so let's start with extend with the Spring extension.class. Is anybody in here warm? I am warm. I'm going to take off my jacket and toss it over there. Okay, great. So the next thing we can show is WebFlux test. What is WebFlux test? Why would you call it WebFlux test? I'm not testing WebFlux, am I? I'm testing my web server. Oh, it is WebFlux. It's a WebFlux base. I haven't even created the web server yet. You'll see that. So this is what happens when you're in a PR and somebody goes, what in the heck does that do? And you have to explain to them. It goes straight into Java doc, and I'm like, this is what it does. Well, what does it do in your words? This annotation can be used in combination with run with or extend with for a typical Spring WebFlux test. Can be used when a test focuses only on Spring WebFlux components. Oh yeah, just like Data Mongo test, this thing is going to exclude everything else except for web-based components, which are the WebFlux components. You'll see those in a second. So essentially, it disables full auto configuration and instead applies only configuration relevant to WebFlux testing. Controllers, controller advice, JSON components, WebFlux configures, things like that. Repository beans they should be ignored. Yeah, beans, but not component, service, or repository. Good. Okay, so now you know your components, your services, and your repositories will not be seen here. And this means something else. This means something important and drastic in our test has to be done in order to provide the component layer that is going to give us the same behavior. This means that I have a repository that doesn't actually go to Mongo anymore. And what do? Mockbean. Yay. So now I have a mockbean of my user repository. I'm going to use Mongo to fill it in. Did I say Mongo? I'm going to use Mockito to fill it in. In fact, this annotation can be used to add mocks to a Spring application context, can be used as a class-level annotation on fields or in either classes or test classes that are run with the Spring Runner. Mocks can be registered by type. Any existing single bean of the same type defined in the context will be replaced by the mock. If nothing is there, a new one will be added, back by the mock. Dependencies that are known to the application context but are not beans, such as this guy, configurable listable bean factory, will not be found, and a mock bean will be added to the context alongside the existing dependency. Excuse me, so that's an advanced case. I'm not worried about that. Let's go into nitty gritty here. Now I have a mocked repo, and I want to say before all, right? And then I want to say public void set up, and I can say mockito.when repo method call find all then return flux just hi new user. I'll give it a user ID of 1234 and the name of John. Right? Good. So now we have a simplified repository that just knows how to react to find all. Otherwise, anything else is going to be like null, empty list or an empty flux or just nothing. Null. What will it return otherwise? I believe it's null or an empty list. Okay. Is it null by default? Yes. Thank you. Okay. So now that we backed our repository, we can start testing. So we're going to do test web find all. And now we have a new component to introduce. I'm throwing out components left and right here. I have a feeling that I need to go a little faster in this test because it's already 7:44, and I have about 15 minutes left. But this is like the last 30% of the whole entire demonstration. And it's all these components that are reactive, that are the most parts that help your edification of reactive technology. And I really want to drive that home because reactive technology is really the way forward, unless you're using Guava or one of the composable future APIs. Those are good too because you use a similar method of testing those as well. So this could help along that end as well. Okay, so what do? I have something called a web test client, right? So what is a web test client, man? So the web test client, it's basically this. It's a non-blocking reactive client for web servers, right? So this is just a HTTP reactive HTTP client, okay? It uses the reactive web client internally to perform requests and provide a fluent API to verify responses. The web test client can connect to any server over an HTTP connection. It can also bind directly to WebFlux applications using mock requests, meaning it doesn't use the transport, it just talks Spring components. It says, here, I have a server exchange, and I want to give the server exchange to the component that reads the server exchange and then returns with the server response. So I don't need to talk actual TCP IP, I can just talk in terms of componentry. And that's what this does. So web test client can be auto-configured. That is, it can be auto-wired, and it will be bound to whatever was imported on your class path. However, I don't tend to do that way. You'll see why in a second. Now, I'll show you. This is one of the ways of doing it. Auto-wired, web test client, auto, right? And this is going to be bound to whatever server it's already found in my class path. However, I don't like that idea. It just bugs me because it means that like anything that's on my server is going to be found and discovered and tested. I don't want to do that. I want to test a single instance. So in this case, I want to bind it to a router function. And that means I have to bind it to the thing that I will receive as a configuration for my web endpoints. So let's do that. So how's everybody doing today? Okay, so now I have a test that doesn't work anymore because I have no user routes. I need to create a class called user routes, and I need to call it a configuration class, right? Because this thing will be found, and it will eventually say, hey, here's the thing that I'm going to use to back my web server. Now, the configuration is going to return a functional reactive component of WebFlux. We're going to use the following: public server response of server request routes. I think I'm doing this wrong, but we'll get there. Don't worry. this the reactive version? Yeah. Let me go back and find out, what did I remember? What did I forget? I forgot something clearly. Oh, where's all your stuff at? Oh, right. Oh, router function. Whew. Wow, I forgot all of that already. Okay, so what we're going to do is use router functions. So router functions allows us to expose routes, and routes are predicates. Router functions allows us to put a predicate on the main webflux route, and that predicate says this is like a get, this has a particular URL, so on and so forth. Public router function route, person, oh, user repository. Repo, okay. Return routes. Dot route. Request predicates. Dot get slash all. This is my function. The route, what route does is it takes a predicate and it takes a handler. This handler essentially gives you the request and allows you to create the stream that will result in the response. Okay, so in this case, what we want to do is we want to respond with an HTTP OK response with 200 and then the body of what was found in the find all method of our repository, right? So I want to say server response.ok, and then I can say then body, and I can go repo.find all, and then I can give it the reify type, and the reify type in this case is going to be user .class, and that's it. Oh, hi. Yeah, don't do that. Yeah, you need that. Okay, so where's our other thing here? Okay. So if you're crying already and you're thinking, this guy, he just PR'd this code, but he messed it to bloody hell, don't worry. It'll happen to you too. No, I'm just kidding. That should never happen to you. Okay, so does this look succinct? Probably, but probably what you want to know more is why am I using router functions instead of the annotation? And the reason why is that annotations bind you to a certain style of declarative programming, which is great because it means that you can just use your annotations, and it can be backed by standard Spring MVC or Webflux. It doesn't matter, you just choose your backend. But in this case, I want to define discretely what is going to happen in my web endpoints. And I like the fact that functional reactive, the router functions allow me to do that because I can be very concise about what the code does. And I can say for sure what's actually going to happen in my code. Here's a predicate, and here's a response, and here's exactly what the server response looks like. So I like that. That's just the way I've learned things. If you have qualms with it, let me know. Or see me over there, buy a piece of pizza, buy me a piece of pizza, and we'll talk about it at length. Okay, so let's move on. So now that we have our routes, and now that we, yeah, it's called route. Now that we bound our web test client to this particular router function, let's talk to it. So we're going to say build. So this gives us an actual instance of web test client bound to that client, right? Then we're going to say get, and we're going to give it a URI, and we're going to say the URI is /all, and then we're going to say .exchange, and then we're going to say expect status, right? So this is our verification script, right? This is our Fluent verification script. We're going to expect status is okay, and then we're going to expect header dot content type, and we're going to say media type dot application JSON UTF-8, and then we're going to do the following now. Now that we've expected the header and the response type, we're going to need to expect the body. And so we can do a number of things to expect the body. So there's some very powerful ways to expect how the body will come out. In this case, I'm going to show you one way of using JSON. I'm going to say JSON path in this case. So what we'll do is we'll write
here today to announce charges.
Path expression.
Largest college admission scam ever prosecuted.
And we'll say the ID and dot is equal to 1234. and that another JSON path, and this JSON path will have the name, and it will be equal to John. Great. Okay, so that's our verification script for the web endpoint. So let's see if this works or not. So we have 1, 2, 3, 4 and John. That's going to come out of our repo. We know that the web endpoint for findAll will return the findAll method, and that's going to be producing a JSON output of John 1, 2, 3, 4, right? So let's execute and see what happens here. Oh, yes. Am I missing one more thing? No. Yeah, return result. One of the other ways of testing this, and how much time do I have? Am I free for time, or am I dying for time? Am I swimming? A few minutes? Okay, so we got a few minutes here. I like to show like lots of variations, because this is all on GitHub, and there's multiple variations of this particular test on GitHub. I do expect you guys to check it out, or check out any one of the Starbucks man's Bootiful reactive stuff, or test. Mine has more tests, so mine just check out that stuff, and it's easy to read anyway. So, and it's in Kotlin and Java, so check it out. That's not the test I just wrote. Why? Yeah, you're right. Yeah. Oh God, that's good. Wow. Okay, so what just happened there? Test ignored, huh? Before all method, public void. Oh, test instance lifecycle per class. That was before all. Yeah, or yeah, have test lifecycle. Yeah, it has to. Yeah. Yeah, I was trying to avoid using before each, but this is a demo, so nobody's going to complain. Okay, so that works. All I did was verify that my web endpoint did the right thing. It returned data, and it created that verification script using the JSON path to ensure that the JSON was right, the body was right, and the status was okay. Now, that's one way of testing it, but let's move on. Let's not focus on our test components. Let's move on to another test component. This one is going to be something a little more complex, because it requires a dimension of thinking that I'm not sure if I even described correctly up front. However, it is very well worth the time and investment in looking at it in that CDC, that's Spring Cloud Contract Verifier. Let's take a look. Let me execute my super duper ultimate shortcut script. I love to use this because it allows me to like type a whole lot less, and I get to get really, really concise with what's going to happen here. Now, I have a plugin. I'm going to use a plugin, and this plugin is a particular type of plugin, Spring Cloud Contract Verification. Now, so this plugin will do a number of things. It's going to first take my contract. It's then going to write rest assured tests against my contract. It's then going to execute against my server behavior. It's then going to create, if it passes, it's going to create an artifact that has a wiremark-backed version of the contract that I wrote and stick it into my .m2 directory or put it into my artifactory. At that point, I can address it and execute that as a daemon on its own right. But before we do that, let's configure it. And so in order to know how the verification test against my contracts that I will write works, I have to tell it, here's how to set up the stage for the server. So we have this base test. And this base test is what's used to set up the stage for the server behavior doing verification of the server contract, right? So we'll say com.example.producer.base class. Okay? And now I can say test mode explicit. So I'm using explicit test mode to say, hey, instead of using mocks, goes directly over the wire. So to do verification, this will actually start up a server, and then it'll shoot requests over the wire. Now I can get out of here after having configured that. Ooh, one more thing: Spring Cloud contract version. That has to be correct. Yep, that's not in there. So let's go back into this trusty guy here. Hi, producer, Palm Spring. There we are. We're going to use 210 release. Okay. All right, so we're going to use 210 release of Spring Cloud contract, and that'll produce our build here. Now let's close everything else out here, and let's go into a base class. And rather than actually writing the base class, I feel like I don't want to do that right now. You guys understand? There's time. People have to eat. People have to get home. You have code to PR. Somebody has to cry tonight. I mean, it's not going to be me, but I'm just saying you got to start somewhere. Let's see, Java class, base class. And I'm not saying that PRs are all torture. They're not. They're cathartic most of the time, many times. Com example, producer. What I did, I just copied and pasted some existing code. You need not worry about doing this in production. So we're going to call it user routes.class. Okay, so let's look at this really quickly. Let's look at these annotations I'm using. Why am I using these annotations, huh? Spring Boot test. First of all, I wanted a Spring Boot test to start up. I wanted to start up my entire application framework, right? What I wanted to do is I wanted to create I wanted to stand up a server on a random port. Now remember, I did test mode equals explicit, so that means that I have to know exactly which port is going to be the server port, right? So that's why I said web environment equals Spring Boot test web environment random port. This allows me to then inject that port number into something called using the local server port annotation into an integer, right? So I have the port that Spring found, and I create my repository, person repo, user repo. There you are. Let's rename you. We don't want to call you person repo. Call you user repo. We'll just call you repo. Okay. User. This was Bob, but this will be changed to John now. Okay. So what we're doing here is we are mocking out our repository. We're not using MongoDB because if we use MongoDB, we're going to have data in there. I'm going to have to save data, and that's just a big mess. You don't want to have to do that. So what we want to do is mock it and create the output that we want, just the stuff that's going to allow us to verify our contract, right? So our contract will be written in such a way that when I call find all, I will return with the user 1234 John, and I will tell the verification unit test to bind to the port that Spring started at the start of this test. So it's going to be localhost : whatever port Spring used to begin. Now, let's go on, and let's say I have a contract, because you want to put contracts in your test resources / contracts. And I want to create a should return all.groovy. This is a Groovy contract. And now Groovy DSL looks much like any other Groovy file. But what do you guys prefer? I want to see a show of hands. YAML or Groovy? YAML? Groovy. Okay. Okay. So let's go with the YAML. Let's delete that. Let's go to return specific. And so this is a specific test. Returns / all. And request is URL all, response status, headers, body, generic JSON. Okay, so this is a YAML file that describes a contract for a request response. This request is a / all for get, and then the response, this is very simple. It could be more complicated. You can put headers in there. Don't worry about that because I don't have, like, the OAuth stuff and, really, really formulaic type of a multi-layered architecture to deal with. I'm just dealing with a sample web endpoint, so it's going to just be URL / all with the method get, and I'm going to have it return a status of 200, or I'm going to expect 200 with content type UTF-8 JSON, and then the body will be this JSON file, this generic.json. So what I did was I created an empty JSON here, and I have ID, and ID is 1, 2, 3, 4, and I have name, and that's John. Now, am I missing anything here? Don't I need brackets? Doesn't it look like I would need like a bracket or something like that? Because it's going to expect a collection back, not a single item. I don't ever usually see that. So let's put that in the collection so it knows how to ferret it out. Okay, so now our contract matches the description that we wrote in our base class, because we want, at the end of the day, for all to return John. So now I can actually run this and cross my fingers a little bit, because you just never know sometimes. Jag SFO, MVN clean install. So if I run clean install, what clean install is going to do is kick off the verifier. It's going to run all of that, verification script. It's going to create the tests, contract verifier tests. So let me show you what that looks like. Now this build failed because I probably have like 8080 or something like that loaded already. Connection refused. Yeah, that's great. Okay, let's see what's going on there. Contract verifier test. Hello. Contract verifier test. Yeah, it never actually finds it. Let's go into target, generated test sources, contracts, example, producer, contract verifier test. Okay, so this is what Spring this is what Cloud Contract Verifier produced. Was a simple rest assured assertions, a set of assertions that say, given this base class, whatever I set up in this base class, do the following: request my given request for /all, and then ensure that the status code from that response was 200, and so on and so forth. So this is exactly like I wrote my contract, only this has been transpiled into rest assured tests. And that allows us to verify that the test actually works, or that endpoint actually works. But now let's go back to this thing here and see what's going on here. What was that error? Managed client, base, generic client. Oh, yeah, I see. Okay, so it was probably somewhere along the lines of localhost 8080, get connection, basic client connection manager. Who's asking for port 8080 in here? Connection refused. Validate specific test, contract verifier test 29. Okay. Yeah, let's see. Web environment port, localhost plus port. Well, that looks normal. Okay. What do you mean, like do this? Well, but wait, you call that localhost 80? Okay, good. Yeah. Well, it should. Well, that's why I put port in here. Did something change? Well, if that's the case, let's do this then. Let's see what changed. It just didn't resolve the port 8080. Now, it could be a small configuration that I missed somewhere. Or it could be the fact that, do we have web config in there? Did we even put web config? Yeah, I'm pretty sure we did. I'm sorry? I would have. So here's what an existing test looks like. It looks exactly the same, only there's Bob here. Mock bean, I have the mock bean, I have the local service port. I'm pulling in my web config. I'm pulling in random port. And then on here, on the web config, I don't have anything specific. It's just a normal actual web route with the configuration class. For this mock bean, let's do that. Let me clean, install. This should run. This is a normal working project. It looks identical to the one here, as far as I can tell. Oh, that's what it is. I know what it is. Okay. So what I've identified was the fact that I have to tell it specifically, you're going to use JUnit 5, not JUnit 4. In order to do that, I have to tell it test framework is JUnit 5. Otherwise, it's going to expect a JUnit 4 test framework and it won't work. All right, so let's go back into my POM file here. And let's do that. Let's add our JUnit test framework and say, hey, we're using JUnit 5, guys. Wave the JUnit flag. Okay. Now, so that should have worked. That was build success. So let's exit out of this guy here. Thank you very much, older demo. MVN clean install. Okay. So so because of that, now you know if you're using JUnit 5, by default it uses JUnit 4, or you could tell it to use Spock also. So either way. Now, what just happened there? Build success. Okay, great. So now we have something that works out of the box here. And for all intents and purposes, the server guy is done. The server guy can now relay over to the consumer guy and say, hey, consumer guy, do your thing. What does that look like? Well, that looks like a guy who writes a consumer application that does a single HTTP call out to port whatever 8080, 8090, whatever port you stand it up on. But in any case, all that you have to do is ensure that the consumer has a HTTP callout to /all. And then you could say, you can configure it such that /all will be backed by my contract. How do you do that? How do you back /all with my contract? Well, that's with Stub Runner. So Spring Cloud Contract Stub Runner is the other side of this. And this allows us to do the following thing. So Stub Runner is basically going to bring in the artifact that I just pushed out from the server side, and it's going to allow me to identify it using autoconfigure Stub Runner as the annotation to tell it you're going to bring in this new module or this new stub. And it's going to say, here's the coordinates to get there, and here's the port to put it on. So it's going to find that thing that I just pushed out that returns 1, 2, 3, 4 in John, and it's going to set it on port 8090. And I'm telling it stubs mode is local because I want it to go to my .m2 directory. I don't want it to go to Artifactory or my remote repository, okay? So as I said before, all that I need to ensure is that I have a standard client that all it does is make an HTTP call out to /all, and it looks like any ordinary test. So in this case, we can do that. This is a pre-existing one, but what we'll do is it will pull down the one that I already built, and it will execute against it. This is Bob. It could be anything, though. It could be a user if I change the properties correctly. But in this case, I don't want to go through all that typing. I want to show you how that works. Okay, so look at what we got here. What did this just do? What the heck just happened here? What is all this JSON stuff I'm looking at over here? Okay, so this is what happens when WireMock gets loaded. Normally I would show you the WireMock test, but I don't need to show you WireMock anymore because Spring Cloud Contract Stub Runner or Verifier already runs WireMock for me. It turns my contract into WireMock, and so this is what that looks like. So we have this definition, this WireMock descriptor that says, hey, I have a request for /ping and get, and respond with 200 and a body of OK. And let's get the actual body in here. There we are. Here we go. So this is it here. So this is my WireMock. It's basically, you can actually cut and paste this into your standard wire. If you're using WireMock already, you can just cut and paste the JSON, and you have yourself a stub. I mean, it's as simple as that. Otherwise, you can just use Spring Cloud Contract Verifier to generate all your WireMocks. That would be kind of cool, but kind of useless too. I don't know if you want to do that. In any case, this is if you're running in Java, but most of the people out there are not only Java, they're doing iOS, Android, COBOL, mainframe stuff, and you don't want to have to bind yourself to one particular language when doing things. So in order to alleviate that, we have the ability to do Docker. We have the ability to run this from a local environment using the JVM itself. I'm going to just show you the JVM version, not the Docker version. That would take a little bit longer. So let's see what we have here. Oh, yes, of course. So what is this? bin/runs.scc.com. Okay, so what we'll do is we'll take, okay, so in order to run this as a local daemon, something that you can spin up and bring down really quickly, you could just use the Java command, java jar runner. So there's the idea that there is yet another artifact called the Spring, it's called the Stub Runner boot. The Stub Runner boot is the thing that allows us to take a stub and execute it and have it stand up on its own. And that's what we're doing here. We're taking the Stub Runner boot dependency and we're directing it to our to the coordinates of our contract, the thing that we just pushed out a minute ago, right? We're just saying here, we're doing this on the command line. Go ahead and find this Maven artifact and put it up on port 8090 or whatever. And then it's going to spin up a standard web server that's, Makito, not Makito, but WireMock. So let's see what that looks like in practice. So let's execute that and do this /bin run SCC demo 8090, example demo 8090. So on port 8090, this will spin up on port 8090 my contract. Now, if I'm a dude, and I'm like, hey man, our web application though, our mobile application has 20 different, endpoints, and I don't want to run them all. I don't want to run MySQL, Redis, MongoDB. I don't want to have to run all these components and, download Docker to do all this stuff. And you can very well do that even with this. You can just have Docker load everything at once. Or you can just load a single instance here, which is what I'm doing. I'm just loading the single instance of this one contract, but you can load multiple contracts here so that you have multiple URLs in this particular server. Now, this is isolated to just the JVM, and anybody with the Java can use this. If you don't have Java, go with the Docker stuff. But if you do have Java, and most people do have Java, iOS developers included, they can just run that. Now, what happens if I try to curl it? Curl localhost 890. Oh, /all. Okay, so then it's Bob123. Okay, and that's it. So that was the contract that I emitted earlier. This is another contract from another demonstration. Don't believe it. Bob's not lying. It's John. On the other hand, you do know that what you now have is the ability to create contracts, verify those contracts, deploy the contracts. You can have them as Docker files. You can have them as your ordinary jar files. You can push them into your cloud matrix where they're consumable through your what do you call that? Your discoverability agent, so that you can back them behind discoverability names. So this is all good stuff. This is really, really powerful, and this should help you really get going with your teams and making people a little bit more happier because I've been pretty mad in the past. In any case, if you guys have any questions, come see me over a slice of pizza and some beer because I'm going to wrap this up and I'm going to shut this down. And with this one slide left, you're going to see some people. I have to show you the people. I don't have to show you anything, really. It's just I want to show you the people. So that's the team. Those are the guys that work all over the world. They're always traveling. They're always up and about. You probably noticed everybody there. Why isn't Starbucks Man in there? Because everybody knows who Starbucks Man is. But there's Nate, there's Jacob, there's Tasha. She runs the whole thing. She's amazing. She literally goes out and makes way for everything to happen for us. Andrew Schaefer, the most insane man who has ideas. That guy has a core star that's this big. Bob Rinley is extremely funny. There's me, there's Michael Cote, there's a Java champion, there's another Java champion, Mark Heckler. Did anybody notice Mark Heckler? Yeah, of course. Mark Heckler is the bomb. And that's it. This talk is shutting down in 60 seconds, guys. Thank you very much. Go to this URL, go to the blog, visit it, and send me your suggestions for anything that you want to learn about or anything that you want me to learn about so that, I can bring it out and espouse it, right? Good. Thank you. And there's links. But you won't have time to actually click these links. This is kind of a tease. Thanks, guys.
So thank you. There will be videos on YouTube which will allow you to grab the slide links and stuff. It'll take a couple days to get those posted. Before everybody runs away for the evening, we do have an announcement. We have kind of a last-minute thing we've thrown together in coordination with the Silicon Valley Jug. We are going to be having a Java 12 launch party next Thursday. We'll be at Oracle headquarters in Redwood Shores. So if anybody's available, we highly encourage people to come. Have an A-list group of speakers going to come out and talk about the new functionality within Java 12. So thank you, and everybody have a good night.